On the island of Stromboli near the Mediterranean Sea, BYU's Department of Geological Sciences spends their time on the beach and deep in the sea.
If you ask any of us, the best place to learn geology is here. We're seeing it in action, we're actually seeing the processes, and when we're in class we can show them slideshows, and that's okay, but it's not as exciting as actually being there.
Tegan Tomlin and other students looked at tide movements along the beachfront. They wanted to be the first to make an important scientific breakthrough about how things move along the ocean.
So what we've done is we've dumped a box full of these pieces of tile, or they're like a brick, and we've dumped them in over there, and we're watching how the waves are pulling them down the shore. And it's a principle called longshore drift.
With their sampling and examination of sediments along the beach, they easily discover what types of rock are inside the sand. Because Stromboli is a volcanic island, the students expect the sand to be full of volcanic debris. The students work on their master's program and write their thesis based on these experiments in Italy. Some students hope to become professors in the future. For example, Tegan will use this experience to make her a more effective instructor for the students she'll teach in future years to come.
When we bring the questions and the inquiry that we're doing here in the study into the classroom, then they can get excited about it and the project can become their own. And when they can see these things happen within the matter of minutes, then I think that geology becomes real to them and it's more exciting.
She's following in the footsteps of her own professors, Drs. Jeff Keith and Janie Radabal. Enough talk on the beach, let's dive right into the Mediterranean. Fortunately for the group, a few of them are certified scuba divers. They suit up at the local scuba shop. Nicole Cox and Jeremy Gillespie head out on the water. They're going to examine submarine bed forms and ocean coral. Their study takes them to the sandy floors over 60 feet deep.
This is an opportunity for us to actually see a cold water environment and corals in cold water and try and discover if they have the same kind of isotopic signatures or are as delicate than in the sense of response to changes in the climate as than tropical corals.
The divers carefully scour the ocean floor for certain types of coral most affected by the cooler water temperatures.
It'd be best to try and find a head coral. Head corals tend to grow radially out, and so you'd be able to see the growth rings.
They cut coral and algae from the rock, bag it up, and intend to take it back to the BYU campus for further research.
We're hoping that actually we can get the same kind of signatures, chemical signatures, from this red algae, branching red algae, than we could have with the coralline structures.
Once they collect what they need, they finish up their dive and head back to shore.